And then we move on to our next speaker, who is Angela Reiner. She's the director of Solliance Solar Research. Unfortunately, she couldn't make it to come to Japan, but we recorded the presentation, which we will show now, about the work of Solliance. In Europe, we use new materials like perovskite, and hopefully that can have a significant increase in the efficiency of solar panels and integrate them also more in buildings, trucks, maybe either other vehicles. And well, let's see what Angela has to talk about from the side of Solliance.
Good afternoon, everybody in Japan. I'm really delighted to be able to speak at the Brabant Innovation Days that are organized by Jorik. Thank you, Jorik. I was invited to present about Solliance. In my role of Director of Solliance, I'm pleased to do so. Solliance is based in the Netherlands, Germany and Belgium and consists of 8 partners that collaborate in R&D regarding solar technologies. And these organizations are TNO, IMEC, Eindhoven University of Technology, Forschungszentrum Jülich, University of Hasselt, Delft University of Technology, University of Twente and Rijksuniversiteit Groningen. In total, approximately 350 researchers collaborate in these 8 partner organizations. And I have the honor to be the director of this collaboration and actually be engaged with all these partners. The Netherlands, Belgium and Germany form a very interesting ecosystem for R&D, demonstrators and also implementation of solar technologies. Solliance grew actually in time. In 2010 it was established by a collaboration between IMEC, TU Eindhoven and TNO. In due course the other partners joined, while nowadays in 2023 there's about 50 companies involved, some of them also based in Japan like Panasonic, and they actually collaborate with the various partners in the Solliance consortium. But we wonder also, why is Solliance important right now? Of course, solar energy has been important in the past decade, but it's becoming more and more important because it's one of the few renewable energy technologies that really can contribute to the mitigation of greenhouse gas emissions. Actually, the IPCC has recently identified solar energy as the most impactful and most affordable climate mitigation measure. And it also then indirectly implies that the European Union, but also countries like Japan and the USA have set renewable energy targets in order to reduce greenhouse gas emissions. And actually, for instance, for the EU, this means that there would be a doubling of the current share of renewables in the forthcoming 8 years. And this requires then innovative solar technologies as well as a very good grid integration for other renewables and storage. And in this context, solar photovoltaics has been growing a lot in the past decade.
This is the time. Solar energy is becoming increasingly important in our society, but we must ensure we make the best use of space in our densely populated country. That's why TNO and its partners are working hard on a new generation of solar panels, products that are beautifully integrated into our living environment, that deliver greater efficiency at lower cost, and that are sustainably designed so as to reuse materials later. We're working with partners throughout the Netherlands on new materials, improved technologies, and customized products on a large scale. We're developing solar products of every size and in every color and shape. Now is the time to start manufacturing this new generation of solar technology in the Netherlands and Europe as a whole, and enable us to meet our own safety and sustainability requirements. TNO is working hard to connect the appropriate public authorities, companies and scientists to accelerate the rollout of new solar power technology. And with the awarded Solar NL Collaborative Programme, we can now really make strides. We are embarking on exciting developments in solar power. This is our time. Would you like to work with us on a range of projects and innovations? Get in touch with us.
Especially in the past year, we achieved a really important milestone, namely that globally the cumulative installed PV capacity actually passed the barrier of 1 terawatt peak of installed PV modules. And this number will grow because in order to meet the 1.5 degree pathway by 2050, there must be at least 15 terawatt peak of installed PV capacity worldwide. And this is an enormous challenge, and that means actually that all the partners in Solliance collaborate to achieve this. So in Solliance, we collaborate with regard to the development of new PV technologies, but also to better integrate these technologies in grids and applications. It's interesting to have Solliance based in the Netherlands because actually, unexpectedly, despite the low irradiance levels that we have, solar technologies are very popular, and the amount of PV systems installed in the Netherlands grew that much that at present it contributes to 16% of the renewable energy electricity fed into grids on an annual basis. And also, the Netherlands are in the top 3 of solar PV systems installed per capita. So actually in the Netherlands we have 1 kilowatt peak of PV per capita installed. And that's really high as you compare it, for instance, to Australia and Germany. Solliance operates in a sort of working group structure. That means that over the whole value chain, from materials to the development of devices and components and systems, and also end-of-life treatment, different topics have been identified that actually are explored by researchers in working groups. And for instance, the most well-known working group in Solliance is, of course, the one on perovskites.
TNO is currently one of the leading players in Europe in the field of research and development of perovskite solar cell technology. With their state-of-the-art infrastructure, TNO has the capability to efficiently process and characterize large area substrates. To deposit high-quality perovskite absorbers and solution-based transport layers on areas up to 30 by 30 square centimeters, we utilize advanced slot die equipment. This equipment is used in inert and ambient environments, and it can handle different ink formulations. An automated lab facility ensures proper handling during crystallization. TNO uses spatial atomic layer deposition to deposit a variety of metal oxides. These oxides serve as transport layers, interlayers and buffer layers for different types of perovskite architectures, including multi-junction and tandem configurations. In addition to spatial ALD, TNO also uses sputtering processes to deposit transport and buffer layers. TNO has different sputter tools to accommodate large area coating requirements. For cell interconnection, we can apply laser platforms with pico and nanosecond lasers. These are used for conventional P1, P2 and P3 scribing, as well as for back-end processing and exploration of innovative interconnection schemes. To safeguard perovskite materials from external factors like moisture and air, TNO has developed various encapsulation strategies for rigid and flexible perovskite modules. By employing vacuum and roll laminators, we can assess the compatibility of conventional and innovative encapsulant materials with TNO's perovskite technology. To evaluate the stability of perovskite devices, TNO offers a range of accelerated tests in climate chambers and large area solar simulators. Under controlled temperature and humidity, we are able to measure the cell's performance during testing. This allows to research failure mechanisms and to optimize lifetime and reliability of perovskite cell technology.
But in addition to that, we also have working groups on, for instance, manufacturing. And manufacturing not only applies to perovskite, but also to silicon photovoltaics. Working group on PV performance, which is mainly on systems, and systems can be applied to many situations like systems on land, systems on sea, but also systems in buildings. And also we have a working group on integrated photovoltaics that is focused on topics like building integrated photovoltaics, agri-PV, and also vehicle integrated photovoltaics. And in addition to that, there's the opportunity to create new working groups. And this is a great way to be very agile in the domain of crystalline silicon and agro-PV. Forschungszentrum Jülich is really well known for their work on silicon heterojunction solar cells, and they achieved relatively high efficiencies, can characterize these cells really well, and also work nowadays on PV applications and specific designs for large area PV-driven water splitting. TNO is known for topics related to applications, and they worked on the prototyping of integrated photovoltaics for cars, virtual twinning for solar parks, and also developed now a mass customization line, which we'll show in the later slides of this presentation. And also they work on perovskites. TU Eindhoven has a very solid knowledge base in perovskite solar technologies, atomic layer deposition, and also in solar concentrators for luminescent applications. And some colleagues work on life cycle analysis. Partners in Belgium, like IMEC and University of Hasselt, have been doing a great job in upscaling perovskite photovoltaic technologies with a high stability, as is shown in the pictures at the lower end of this slide. But also they have great experience in silicon wafer PV technologies and systems. Rijksuniversiteit Groningen has a very solid background in fundamental materials research. It's actually shown by their work on open source models for perovskites, but also organic solar cells. And University of Twente have gained great experience in big data analytics of the performance of large fleets of PV systems in Europe, and also have a rich background in designing with photovoltaics, as well as luminescent solar concentrators, together with TU Eindhoven. This framework that I show now, which is called Designing with Photovoltaics, will become more and more important in the future. And it is also one of the background theories of the work done by Solliance. For instance, in the past decade, enhancement of manufacturing and also improvement of technologies for photovoltaics have been a driving force behind research and developments. And this is also then associated with reduction of costs. So financial aspects have been very, very important in the development of new photovoltaic technologies, but also new types of PV modules. However, the social context becomes more important, especially by policy, like the targets set by governments, but also the environmental regulations, aspects related to integrated solar technologies, not just in systems, but also in buildings, and also in automotive, but also in products, has become more and more important. And it means that in that domain, human factors like interaction with photovoltaics, but also their perception, which is then actually stimulated by good design and styling, will become more and more important in the near future. And actually, this is then resulting in interesting new types of PV modules that are colored or curved or maybe 3D structured. This is explained in one of my books called Designing with Photovoltaics.
Solar energy is one of the pillars of our energy transition. Today, the vast majority of solar energy is generated using traditional solar panels. But the time has come for the next generation of solar technologies. Over the last few years, demand for solar energy in a variety of shapes, sizes and colors has grown. Innovations in flexible foils, bifacial modules and semi-transparent elements offer new opportunities. The challenge now is to integrate these new technologies into existing production processes. At TNO, we face this challenge head-on. Within the program Mass Customization, we're developing a cost-effective way to enable the large-scale production of customizable solar laminates. A solar laminate is a semi-fabricate that can be processed into an end product. These solar laminates will be made in a production line that enables various sizes, shapes, and electrical power. They can be easily added to end products such as building components with integrated solar energy. Of course, they should fit seamlessly into the existing production processes for those building components. This way, end products will be cost-effective, and solar energy integration will become a common feature. We're now focusing on the development of the pilot production line. It will serve as a blueprint for future production on a larger scale. The shift from standard solar panels to solar laminates offers excellent opportunities for both innovative existing companies and startups. We are looking for partners to join us in the further development of mass customization, to help us develop these semi-fabricates and to make them available for construction, infrastructure and automotive industries. Together, we can enable a smooth integration of solar energy into existing production processes.
Solliance also organizes network events that are meant to bring companies together and to discuss certain topics that are relevant for the solar sector, like for instance the circular economy and how to handle waste originating from worn out solar panels. Solliance has a newsletter and also has news items on LinkedIn. So if you want to follow what Solliance is doing around the theme of solar research, please connect to us on LinkedIn.
So thank you for listening. I hope I've explained well how Solliance functions and what sort of R&D we execute. Naturally, if you have questions, then please contact me at my email address shown on the slide. Hopefully I can come over to Japan another time in the future and connect in person. Thank you.
Although Angela was not here via live connection, I want to thank her for her presentation. If you want to be in contact with her, maybe you saw and noted her email address. If not, you can contact me, so I will bring you in contact with her.